Hello everyone. Uh, Today I will be doing the next project in the Arduino starter kit, which is project 6 titled Light Theramin. So we will be using a photo transistor to determine the height of like your hand, like this, and then depending on how high it is, it will play a noise or a certain tune. Okay, so now that the circuit is on the screen, let's start building it. So I'm gonna need a photo transistor, a 10k ohm resistor, and a piezo speaker. So got my photo transistor, then the piezo speaker is this guy, has 2 pins. And lastly, get my resistor out. This guy, 10k ohm. So looks like it should be a pretty simple setup. Yeah, so let's put this in. I believe it doesn't matter which direction you put it in. Yeah, it shouldn't matter, so I'm gonna put it in. It's hard to see the number. It's 5 and 9. That covers it. Let me just double check. Yeah, so it's connected to row 5 and 9 on the breadboard. So, knowing that, let's do our ground and power connections. So, ground to 5. Wait, it's actually super hard to plug in. Okay, so do this first. Ground to 5. So plug in our speaker. That. Okay, and then let's connect our other end to our board, which we can put to pin 8. Let's do so. Pin 8. It's going to pin 8. Okay, cool. In focus now. So next is the photo transistor. Right, so let's plug this in. And again, we have a longer end and a shorter end. So we're gonna connect the long end to power. So let's do that. And then the shorter end, we'll connect to ground using a resistor. So okay, and next we will connect that to our analog pin. That right, yeah. Connect it to A0. Okay, so the hardware component of it is set up. So let's get to the code. Okay, so let's see. So to start out, we will declare our variable for sensor value. Oh, hello. Then also declare our low values and our high values. It's just going between 0 and 1023. And then we will also declare our pins. So this LED pin 13 actually refers to an LED on the board, I believe. We're not actually connecting an LED, but it should just be a built-in the onboard built-in LED. We're gonna use that to debug. So moving on to the setup. Declare our pin modes. Pin mode, LED pin, output as we want it to do something. Digital write, LED pin. So we want this to be on initially. And then next comes the calibration code. So this function while says that while millis, which is another function, who else? Okay. And then we're gonna say millis is less than 5,000. So basically what millis does is it starts a timer, and then so it's gonna say, so while the timer isn't at 5 seconds, while it's less than 5 seconds, then it'll do something. So that's our calibration stage. So next we set up our sensor value equals analog read A0, which is our phototransistor. Then, so we're going to say if sensor value is greater than sensor high, oh, that's not. Sensor value equals sensor high. So basically it's saying that, or sensor high equals sensor value. But this is basically saying if if our phototransistor detects a value higher than our upper limit, then we change the upper limit to be the new value that the phototransistor is reading. So then the other case is if it's lower than the lower limit, then we will change the lower limit to the currently inputted value. And then lastly, now that the calibration phase is over, we will turn off the onboard LED. So that's it for the calibration code. Next we will go into the loop. So first we will start reading our sensor value. So, and then we will make a new integer, integer called pitch. So it determines the pitch of the speaker, and we are going to say that this is equal to, so we're going to use the map function again, sensor value between, so we're going to take it between sensor low, sensor high, and then we're going to map those values between 50 and 4000. So the 50 and the 4000 is going to end up being the pitch or the frequency of the note being played by the speaker. So we're saying it's going to go between 50 Hertz to 4000 Hertz. So lastly, we're going to use the tone function. So the tone function actually tells it to play something. So the 8 refers to the pin that it's connected to. Pitch is, as I explained before, the frequency. And then lastly, we're going to use 20 for playing it for 20 milliseconds. Then all we need to do is add a delay, and that should be good to go. So let's plug this in and upload the sketch. Just hide this. Okay. But let's upload this. Okay, looks like it finished uploading. So, oh, didn't get to calibrate, so we reset it, and then we start moving our hand up and down, and it should calibrate the sensor. And it's still hard to hear, but it's starting to make some noise. Let's try this again. I'm gonna try and do it. No. I don't know if you can hear, but it's buzzing. Putting it to the mic. And then it changes pitch depending on how far away I place my hand. yeah, depending on how far away my hand is, the speaker plays a different note. Let's try putting more light onto it. So yeah, just changes pitch. Then this light right here, that's the LED that we were talking about on the board, and then when it turns on, we know that it's in the calibration, and then when it turns back off, then that's when it's actually working like normally. So let's show that again. Turns on initially, but then you calibrate, and then the light turns off. So that's pretty much it for this project. Let's see if there's anything. Oh, and put this. So yeah, that's it for this project. Thank you for watching part 6 of my Arduino starter kit series. So that was taken from my stream last week, and I actually wasn't able to stream today. I've been feeling a little out of it recently, so hopefully I'll be back on Thursday with more energy. But yeah, so I'll plan on another upload on Thursday, hopefully coming from a stream highlight where I play around with the LEDs and revisit some of the previous parts from the starter kit, previous projects. So please follow for that if you'd like, and once again, thank you for watching. I'll see you in the next video.